Good afternoon, my YouTube viewers. It's Crystal here. I just wanted to do a code review for you using Jax Logistic regression, and we're going to be using the sklearn's toy data set on breast cancer to do this. And so basically, what I'm going to do is, first thing I'm going to say is this: today, when I got home, I got some hate mail from somebody saying that they don't like my accent. Well, I can't do anything about my accent. It's a lot milder than it used to be, but if you don't like my accent, you don't have to watch my videos. That's the only thing I can say. And then now that we've touched upon the hate mail I received, then what I will do is I will go ahead and commence with the code review. And basically, we're using Jax, which is a new library. It was made in about 2018, I believe, and it's supposed to replace TensorFlow for site research purposes anyway, because Jax doesn't have a keras in it, so it's more difficult to work with Jax. You have to get down to the bare bones. You get closer to the computer in Jax than you do keras. And although I like keras a lot, you don't get that with Jax. So we're going to work on the logic regression model. I did actually use ChatGPT to get the model, but I modified it. So, but you can't always use ChatGPT. Every time you try to get something out of ChatGPT, you have to check it and make sure it works. So that's one thing that you need to do. But I did get this out of ChatGPT. It worked, but I modified it. I made a lot of changes to it. So the first thing we're going to do is we're going to create our Jupyter Notebook. And I created my Jupyter Notebook in Google Colab, which is a free online Jupyter Notebook hosted by Google. The only thing that I don't really like about Google Colab is it doesn't have a very good undo function. But, so you have to try really hard not to accidentally overwrite or delete any work. So that's one thing that you need to keep in mind. So now that we know what platform I've used to create this Jupyter Notebook, we're going to import the libraries. So we're going to import Jax, and that's the main library because that's what we're studying. We're going to import jax.numpy as JNP, and jax.numpy is very similar to the NumPy API. So if you know a little bit about NumPy, it'll be easier to learn Jax. We're going to import sklearn datasets. We're going to import sklearn train test split, which I thought about doing it just using NumPy, but I thought, oh well, I'll go ahead and use train test split. But you could do it. I do have some code where you can do it just using NumPy. We're going to import pandas as PD because we're going to create a data frame so we can make a heat map. We're going to import sklearn to visualize the data statistically, and we're going to import matplotlib to visualize the data. So after we have imported our libraries, what we're going to do is we're going to load the data set. And we're loading the breast cancer data set, not the iris data set. Okay, so then data equals datasets.load breast cancer, x equals data.data, y equals data.target. So we're going to check the unique values of y. You've got two unique values because this is a binary classification. And then y is going to be your target. So we're going to print the unique values of y, and we're going to print the x shape, which is 56930. we're going to use Seaborn to analyze the target. So you can see that this is an analysis of the target. So I'm assuming that 0 means they don't have breast cancer and 1 means they do have breast cancer. So you can see that in this data set, more people have breast cancer than don't. So we do have a bit of a class imbalance. And there are some things that you can do, like you can balance your weights and things like that to deal with the class imbalance. But I normally do that with sklearn. I haven't learned how to do that with Jax yet. Now we're going to use Seaborn to create a heat map. But before we could create the heat map, we had to convert X to a data frame. So dfx equals pd data frame X, core equals dfx.core, and sns.heatmap.core to create your heat map. And then we can print the correlation out. And then what I wanted to do is at first I thought, well, since there's like over 30 columns of data, let's see how many, 30 columns of data. At first I thought, well, what I'll do is I'll just delete all of the columns of data that have a high correlation. But what I found out was the accuracy of the prediction was significantly less when I deleted the columns of data that had a high correlation. So what I'm doing here is I'm just showing you the columns of data that have a high correlation, but I'm not dropping them. Okay, and then you're going to standardize your data. I think with logistic regression, it's not really necessary to standardize the data, although some people do. But I checked it. I ran the computer program up with standardized, and it was slightly less than it was when it wasn't standardized. So the name of the game is to have the highest accuracy you can get. So that's the formula for standardizing your data, even though I didn't use it. And now what we're going to do is we're going to use sklearn's train test split to split the data. So now you've got train, X test, Y test. And so you can see that, which I do have code where you don't have to use sklearn. And I might try to go ahead and replace the code where you don't have to use sklearn and see what happens. But what I found, because I was working on linear regression, and I found it was really hard for me to do the train test split manually, but you can do it manually if you want to. And then now what we do is we've got logistic regression. So we're going to add a bias term to the features. So basically what you're going to do is it's going to add a 1. It's going to add a column of 1s to the train set and the test set. And you can see here where it's added a column of 1s to the train test and the test set. And then we're going to define the sigmoid function. And so def sigmoid return 1 over 1 plus jnp.exp negative x. So that's your sigmoid function. And that's what's going to create your logistic regression. We're going to initialize the weights. Num features equals x train.shape 1, because that's the number of columns, so that's your features. Key equals random.prng key, and we're going to use 42. And weights equals random normal key num features. Now we're going to set our hyperparameters as learning rate is 0.01 and number of epochs is 1000. And we're going to set up our training loop. It says for epochs in range num epochs Logits equals JMP dot dot X train weights. Probs equals sigmoid logic. We're going to compute the gradient of the loss of binary cross entropy. Grad loss equals JMP dot dot X train T. T means transverse. Probs minus Y train, then ln X train. We're going to update the weights using gradient descent. So weights equals weights minus learning rate times grad loss. Now we're going to make predictions on the test set. Test logits equals JNP dot dot X test weights. Test logits equals sigmoid. Test logits predicted labels equals test probs greater than or equal to 1 dot as type int. So that means if it's greater than 1, greater than 0.5, then it's a 1. And if it's less than 0.5, it's a 0. Then we print the predicted labels. So you see you've got lots of 1s and 0s. And now what we're going to do is we're going to calculate the accuracy and depth accuracy metric, actual predicted, correct equals 0 for I in range, ln actual. If actual I equals predicted I, correct equals correct plus 1, return correct over float, ln actual times 100. And then so accuracy equals accuracy metric, Y test predicted labels, print accuracy. And so you've got an accuracy of 92.98. So that's good. And so that's the logistic regression on breast cancer. But I intend on doing some more. And I intend on working on Jax a lot and learning Jax a lot. I will say that it's close to NumPy. It's not exactly like NumPy, but it's close to NumPy. And so if you know how to use NumPy, then it'll be easier to use Jax. So I'm going to go ahead and close the video now. I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you so much for watching my code review. I look forward to making more code reviews for you in the future.